Good morning. It's a nice Friday morning, 6:12 a.m., and I'm here sitting and wanting to provide you with this good information on partial correlation. So if you recall, on Wednesday when we met, we didn't have my video on so you can see what I'm doing here. Hello. So we had this information that I unfortunately wasn't able to present to you at the time just because we had to take our quiz. So let's go ahead and do it right now. We talked about a correlation itself, a correlation coefficient, and we went over the equation. We actually called those correlations that we did zero order correlations. They don't control for any other variables. I did give you that example of how if we look at ice cream and murders and so they're correlated and say, oh, what? How could they be correlated? It doesn't make any sense, but they're correlated because they're both related to the summer. People tend to eat more ice cream in the summer, and sadly, there's more murders when people are out in the summer. So that that means that the reason for these two variables being related is that third variable, something we call the third variable problem. That variable is also known as a confounding variable. Confounding variables are variables that are related to both like a predictor and an outcome variable, right? Those are called confounding variables. And the best way to control for them is to include them in whatever you're doing. So you kind of control for them through their inclusion. So here we're going to you calculate what's called a partial correlation. So a partial correlation does the controlling for the third variable, for the confounding variable. And you can see this in an example where we have two variables, variable A and B. This is hypothetical, of course. And we're controlling for variable C, that third variable. So it's kind of a simple equation if you think about it. It's just a correlation between the two variables, and from that you subtract the product of the correlation with each variable and the confounding variable, where C is the confounding variable. The denominator is just a square root of 1 minus, well, it's that R square, right? 1 minus the coefficient of determination. So that's not a horrible equation, but we want to make sure that, like everything else that we do, that you always set your problem up correctly. And like an accountant, I always think of an accountant. An accountant always does everything correctly, as say by the books. Well, they usually do the books, right? Okay, so using the correlation matrix below, calculate by hand the partial correlation for depression and self-esteem, controlling for perceived physical appearance. So here's a regular correlation matrix. Correlation matrices generally have ones running down the diagonal, okay, because these are standardized. And this is basically the correlation between a variable and itself. And of course, it's going to be one. You can also think of this as being the variance, because these are standardized. So the variance is one. The other cells are populated with things like the correlation, of course, that's what we want. The p-value, so here it says significance two-tail. So this is the p-value associated with whatever you're calculating. By the way, 0, means it's certainly less than 0.0001. So that's usually what I put when I see just 0. And what else do we have? And some degrees of freedom. Excuse me. So this is your prototypical table, and what you find above the diagonal is equal to what you find below the diagonal. So it's symmetrical. So you only need 1/2. And because of that, in many papers that you read, you'll see people using, when they do provide a correlation matrix, they use one of these triangular spaces for something else because they don't want to repeat the same thing. So they might put some other values in there. All right, so let's go ahead and do this. So here's your correlation, and in my beautiful handwriting, I did this for you. So we have, again, here's the equation written down. The correlation between, oh, let's see, what was I doing? Sorry, I'm going ahead of using correlation. Calculate the partial correlation for depression. So variable A is depression and self-esteem is variable B, because depression and self-esteem are strongly related. In fact, you can see it here. The correlation is minus 0.692. Again, in the beginning of the semester, I think it was maybe in the first or second class, I gave you the code sheet for my first data set. So you should know you don't need to ask me what these variables are. You can always look them up in the code sheet. So they're strongly correlated, right? That's about 49% of the variance is shared, right? Because 0.7 times 0.7 is 0.49. All right, and then our control variable is perceived physical appearance, how you think about yourself and your physical appearance. So let's see how that affects this correlation. So we have the correlation between depression and self-esteem. I believe this is depression and perceived physical appearance. Go back to here. A and C. Yes, A is depression and perceived physical appearance. So you're subtracting that. You're also subtract. Now notice that's a negative sign, right? So I have these brackets around this product because a negative times a negative is going to be a positive. Then you have here self-esteem and perceived physical appearance. So self-esteem and perceived physical appearance are highly correlated themselves. Means if you think you look good, you probably feel better about yourself. Okay, so you divide this by the square root of, as I said, 1 minus the coefficient of determination for this product right here, this correlation right here, right? And then also for this correlation. And then we get minus 0.59283. Just make sure you do this correctly. The important part is what did we learn from here? So the original zero order correlation was 0.692, negative 0.692. So self-esteem and depression are negatively related, including the third variable or controlling for the third variable. We reduced it to 59.283. So it was part of it, it was part of it. So we went down from 49 to 36% of the variance, right? You understand what I did? I just squared this to get the proportion of the variance. I squared that, so we went from 49 to 36, so like 13% decrease, right? Percentage point decrease, I should say. All right, so let's go back to the next part here. So we didn't do these SPSS examples. So using my first data set, calculate the following correlations between depression and self-esteem, calculate the following between depression and self-esteem controlling for perceived physical appearance. We want the bivariate Pearson correlations, the bivariate Spearman correlations, and the partial correlations. So 3 different correlations. We can do this in 2 different steps. So let's go to SPSS here. So I have my first data set up here. So let's go ahead and do this. So we'll go to Analyze, go to Correlate, and we want bivariate correlations. We're going to start with the bivariate correlation. You can get confidence intervals as well. Bivariate correlation. I always right-click because I prefer having the variable names here. That's just my preference. So let's do depression, control, self-esteem, perceived physical appearance, and put all this in there at the same time. We want the Spearman correlation. Kendall's tau is good when the sample size is small. It's equivalent to the Pearson correlation. Look at the options. Always good to get means and standard deviations. You don't really need these cross product deviations and covariances. So if we were doing something by hand, this would be obviously very helpful because now you get the numerator for your equation here. I'm not going to do confidence intervals. Okay, I'm not going to do any of this. Let's style. Nothing interesting there. All right, hit OK. So here we have our correlations. Obviously, this is the same thing that we had in the table that I gave you because there's the same problem that I used. Get minus 0.692. And, I'm going to try to suppress something. Let's see, just so I wanted to see what this looks like. I'd like to just give you a view of a prototypical correlation matrix, just without anything else. Let me see if I can do that, but I don't know if SPSS has to give you everything. Let's see. Show only the lower triangle. Oh, that's interesting. So that's interesting. Options. What about? I don't know if I can give you that. Show only the lower flags. Yeah. I guess it has to show you these significance values. Okay, so that's all right. So, so this is your prototypical correlation matrix. So, and you'll notice that you have two different ones. You have the Pearson. So Pearson, this may or may not say Pearson. It just says correlations, right? I just say Pearson, okay. And then here it should say, it says non-parametric correlation as a Spearman's rho. Non-parametric means we don't assume a distribution, right? That's all it means. So let's see, what did it change much? Went from negative 0.692 for self-esteem and depression to minus 0.641. So there's some change, but not, massive. 446 to 423, and then let's see anything else. Where am I? I'm missing one. 591 to 558. Okay, so there's some change. Correlation shrunk a little bit. Non-parametric equivalent is usually more robust. It means it can deal with problems with violations of some of the assumptions. All right, so let's go to the next. So that's the first two. The next step would be to go back and hit analyze, correlate, partial correlations. This is what we want now. So again, we're doing the exact same variables. Like in this case, let's see, exact same variables here. We have depression, self-esteem, and we're controlling for perceived physical appearances. Controlling for, right? Display actual significance level. Okay. Options, we have, put the zero order. So the zero order means the correlation before controlling for third variable. And if you want means and standard deviation, not a bad idea because most people always ask for those. If you're wondering what bootstrapping is, that's kind of an interesting phenomena when we don't have, say, a normal distribution. So we say, okay, well, we'll just use the distribution we have and we'll sample from within there and create our own sampling distribution. So it's a way to deal with when you don't have normal data. And hit OK. So get a similar correlation matrix, except for now it says here, none, and then it shows the perceived physical appearance. So it gives you a direct view of what we have for the zero order and the partial correlation. And you'll see this is exactly what we had before. We had a minus 0.692. And then we have a minus 0.593 partial correlation. So again, we have the same result as we had before. Here's a quick question for you all. Which correlation is stronger? The correlation between perceived physical appearance and self-esteem, 0.590, or depressive symptoms and self-esteem, minus 0.692. If you said 0.590, you are wrong. Remember, we ignore the sign. We look at the absolute value for strength. Negative 0.692 is much stronger than positive 0.590 because if we take the absolute value, 0.692 is larger than 0.590. Well, I want to thank you all for sharing this nice Friday morning with me. And thank you, and I'll see you soon. Bye.